Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is John from Business Review, an NS Media company, and I'll be your host today. It's our pleasure to have Donaldson with us today. We'll be presenting this webinar entitled, Help Protect Powertrains with Venting. Today's guest speakers are Dustin Waller, Product Development Engineer, and Stan Bani Uwembo, Application Engineer. I'd like to welcome you to our webinar platform on 24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link you receive via email to rejoin the session. In order to ask questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click submit. We will allocate some time at the end of the session to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of these slides. Thank you, everyone. Now, please allow me to welcome Stan.
Thank you, Jonathan, for that introduction. I also want to thank everyone in the audience to take the time today to be here in this webinar on how to protect your powertrain application. First of all, who is Donaldson? Donaldson is a filtration company founded over 100 years ago in the US. We are a global company present in almost all continents, and we have over 14,000 employees at the moment. We invest every year 3 to 4% of our revenue in R&D, which has led already to over 1,800 patents on the Donaldson name. Donaldson serves a lot of different industries around the globe, of which some of them are shown here on the slide. We combine different technologies, different shared lessons from different industries together, so we can optimize our products for a certain industry. So today I would also like to have a small question to start, and I will give the word back to our host, Jonathan.
Thank you very much. So now it's time for our first polling question. So for the audience, you can click on any of the options listed below, and we'll have a look at the answers shortly. This question reads, on a scale of 1 to 5, 5 being the most familiar, how familiar are you with the venting powertrain components? Dan, is there a particular reason why you asked this question today?
We would like to know the knowledge of the audience about this topic, and see how familiar they are with how to protect powertrain applications.
Perfect. Thank you very much. So we'll just quickly have a look over the answers now. And there we have it. So we have 35.3% on 2, followed by 29.4% on 3, followed by 17.6% on 1, and followed by 11.8 and 5.9, 4 and 5 respectively. Dan, are these the results you're expecting?
Yes, we expected the audience to have a little bit less familiar or basic knowledge level of this topic. So you have come to the right place, because today we will start with a basic level discussion about this topic, but we'll also move further on to a more complex level. So today we will discuss how to protect your powertrains with venting solutions. So a small overview of what we will discuss today is, what is venting? Why is it needed? Secondly, what are the unique challenges for powertrain applications? Thirdly, what are the advancements of Donaldson in this powertrain venting? And at last, how to validate such a venting solution. So first of all, why venting? As we see in automotive applications, we see that there is a free air volume entrapped in the enclosure, and this results in a certain pressure inside. But if there is a temperature change or an altitude change, the pressure inside or the air volume inside will change. So the air volume will shrink or expand depending on overpressure or underpressure. The result of this will be that there will be strains present on the seals and gaskets of the unit. And if those strains are going too high, seals and the gaskets will start to leak. One solution for this problem would be to make a hole in the enclosure so the air inside can freely communicate with the outside environment. But at the same time, this hole in the enclosure is an open pathway for contaminants, water and dust to come in. Another solution would be to use a permeable membrane. So at the same time, it will let airflow going through in a bidirectional way, so equalizing the pressure inside, but it will also keep water, dust, and contaminants outside while maintaining the integrity of the vent. Donaldson proprietary ePTFE Tetra-Tex membrane, also called Teflon, is the core technology behind our venting solution. It has a unique micropore structure with small randomly connected fibrils at nodes that can be used as permeable water barriers, so basically being watertight, while the pores still let the airflow go through. Donaldson proprietary oleophobic process also makes the filter repel oil contaminants. So at the same time, the membrane will be hydrophobic as well as oleophobic. This ePTFE Tetra-Tex is used in multiple markets, of which some are shown on this slide, like microfiltration, syringes, industrial filtration, membrane distillation, but also in the automotive sector, which we will today focus a little bit more on. If you look at the vehicle, there are multiple venting components possible, where some applications where the venting solution is needed. Some of them are listed below, like automotive sensors, lighting, horns, electronics, motors and pumps, hybrids, EVs, powertrains, fluid reservoirs. All those different applications have different requirements, so Donaldson has different configurations of our ePTFE Tetra-Tex membrane for the different applications, and some of those standard components are shown on the right on this slide. If we look at potential vent locations for powertrains more in detail, we see that for the conventional powertrains, there are multiple vent locations possible. Some of them are like transmissions, power transfer units, axles, differentials. But we also see more and more similar leads for EV powertrains, because they have similar requirements, like e-transmissions, traction motors, e-axles. But what is now the unique challenge with powertrain applications? In these powertrain applications, there is a lubricant present. If the components start to rotate in this lubricant, it will create a sling region for the oil, but it will also create an oil aerosol which will become entrained in the air volume. But after long-term continuous exposure, this oil aerosol will create an oil film layer next to the vent, which will prevent the vent from letting airflow through, and so it will stop the pressure equalization. This even happens when the membrane is oleophobic coated. Today, there are already some common venting methods for powertrains, like a recycle cap or a hose breather. So basically, you connect the hose to one side of the housing, and the other one is to the open environment. Most times, the top opening of the hose is presented above the water falling level, so it acts like a snorkel and no water will be going in. But at the same time, a big disadvantage is that contaminants still can go inside, and that the oil aerosol can go outside, contaminating other components of the vehicle. A second solution could be a membrane-only vent like our Donaldson ePTFE Tetra-Tex membrane. But as mentioned before, after long-term continuous exposure, an oil film will be present, which will stop the pressure equalization of the vent. A third solution could be to use a sorbent media vent. But after time, it will reach its saturation point and will start to plug. At that time, it will also stop the pressure equalization function of the media vent.
Dan, thank you very much for the introduction. My name is Dustin, and I'm going to be covering some of the advancements in powertrain venting technology, as well as some of the validation efforts in the development of the powertrain vent. As Stan mentioned, the ePTFE is a popular vent medium already used in the automotive sector for various applications. But when exposed to oil aerosol, it can film over, which causes a loss in airflow. And this is one of the most, or one of the more unique issues with the powertrain venting. Donaldson, having 100+ years in filtration expertise, set out to address the filming issue with its proprietary Syntec XP media. So what is the Syntec XP? The This technology was developed specifically to reduce crankcase emissions in PCV applications. So the venting group then took this technology and adapted it into the powertrain vent in order to coalesce the oil aerosol present within the airstream in drivetrain components. So what we did was a customer axle was used and customer fluid was used, and the component was run under various operating conditions in order to produce this oil aerosol, which was then characterized and profiled to understand the venting or the filtration approach needed to filter that out. So Donaldson then selected a particular Syntec XP grade to target the oil aerosols within the powertrain applications. So this Syntec XP technology, combined with the water tightness of the Tetratex PTFE, allows for effective venting of the enclosure while helping to maintain the life of the PTFE membrane, which is the real workhorse of the venting solution. So here we can see the screw fit configuration of the powertrain vent. This is kind of an exploded view to show some of the internals working within. On top we have the vent cap, which in combination with the venting windows on the sides of the head help give water spray protection to the PTFE membrane. Beneath the membrane is the rib support structure, or the media retention disc. This serves two purposes. One, it provides support to the backside of the membrane during a water fording event or when water pressure is applied from the outside of the vent. This helps reduce the deflection of the membrane and resist that, providing support. It also provides a physical barrier between the Syntec XP media and the membrane media up above. And all of this is in a fairly compact screw fit package it all together. In this configuration, all of these components are combined to a low profile integration, which provides the pressure equalization that Stan mentioned was important for venting these powertrain components. It keeps the oil inside the system, but also keeps all of these contaminants outside of the system. Just as an idea of scale, this screw fit vent here is an M20 diameter. So in addition to the screw fit configuration, there exists the hose fit configuration. These are more popular for applications like a rear axle or differential. These are also popular in situations where ease of integration is critical. There may be a hose barb already existing on an axle that the design is fixed on, and that hose barb may have gone to a jiggle cap or snorkel arrangement. And this allows the hose fit vent to drop in with little to no modification to the existing design. Same core technology of the Syntec XP media as well as the Tetratex PTFE is deployed in this hose fit configuration as well. on to the validation package, there are many things to consider when working to validate venting technology and how it relates to the robustness of the drivetrain components. Donaldson focused first on evaluating the Syntec XP, as this was a new addition to the venting approach for drivetrain components, in addition to the already existing PTFE technology. What we're looking at here is the result of an oil wick test. Simply put, this test was to evaluate the level of liquid oil resistance possessed by the oleophobically treated Syntec XP, and then how that compares to a more conventional approach of an oil sorbent media stack. So this was accomplished by taking the sorbent media stack, which you can see at the top left of the screen, and this was installed into a clear housing to allow for observation of the stack during the test. And then this housing was submerged just below the oil level line so that there's liquid oil exposure to the bottom of the stack. So the clear housing was then suspended on a mass balance, and this helped us to quantify the ingress of oil via gravimetric analysis. Looking at the top part of the graph here is the sorbent media stack. And what we can see is that immediately it begins wicking oil. You can see the mass increasing as you move up. And at about the 45-minute mark, which you can see at the knee in the graph there, this media has fully self-saturated. So it has wicked oil to the point where it reaches steady state. And after that point, no appreciable change in mass was observed. In contrast, here is the Donaldson oleophobic Syntec XP media at the bottom. You can see on the bottom left in the image. And so you can see that this has quite a bit more resistance to that wicking of the liquid oil. So even when submerged and in contact, it resists this liquid oil ingression. You can see in the images it remains white and free of oil. And also, even after 7 hours of exposure to this liquid oil, the Donaldson oleophobic media has 30 times less oil ingression than the sorbent media. So this test illustrates the liquid oil resistance of the pre-filter media. But another key question is, how does it do against oil aerosol? Now, this is the most challenging component of the powertrain venting problem. Prior to on-vehicle testing, and this after the wick testing, the assembly was evaluated on lab equipment on a lab scale using aerosol generators, which simulated the actual component aerosol generation. So a customer component was run on a lab stand test and run through the duty cycle so that we could characterize and profile the particle distribution, and then we could come at it with a theoretical filtration calculation in order to take care of that filter contaminant. So once this was studied in the lab and we characterized the particle distribution, we then simulated that distribution on an aerosol generator test bench in order to study empirically the effect of the filtration media. So here we see the result of a fully assembled Donaldson powertrain vent, and this was tested on a customer axle spin test. This was in operation on the axle for 150,000 miles, so about 241,000 kilometers. And then the vent was removed for inspection. On the left image there, you can see this is the Syntec disc that's at the bottom of the stack, so it has the closest level of exposure to the oil aerosol. And in the red encircled region, you can see several droplets of liquid oil that have coalesced on the media fibers. This is at 200 times magnification level, and at equivalent magnification level on the right image is a little bit further up in the stack of another piece of media. And here we see very little to no evidence of oil coalescence. This observation shows that the liquid oil is coalescing within the stack, and it shows that the theoretical collective filtration efficiency is seen throughout the stack. And as you get higher in the stack, there's less and less evidence of oil exposure. In addition to the lack of observed oil, the airflow rate of the powertrain vent in this test was not affected by the aerosol loading test, even after 150,000 miles. So here, the differential pressure was nearly identical to the new and clean vent, which we used as a control sample. And the change in airflow was within the natural variation of the new clean product itself, which means that there was no appreciable impact to airflow after this level of exposure. So this suggests that the theoretical calculations for filtration efficiency do correlate with the empirical data we took in the lab, and this helped us understand that this particular grade of Syntec XP media was effective at collecting the oil aerosol. In addition to the lab testing, Donaldson moved forward with on-vehicle testing to understand the performance of the part in situ. Here what we can see is an example of the large hose fit powertrain vent. This was installed on an axle in a 4x4 passenger vehicle application, and this was subjected to a customer durability test. What this includes is some on-road driving, off-road driving and trail driving or dirt road driving, as well as water fording. And this onslaught lasted in total about 165,000 miles, or about 266,000 kilometers. So in the left image in the upper left, you can see the cap was removed from the vent body and the PTFE layer is now visible. And so we do see some evidence of exposure to dust and debris. This is deposited on the outside of the membrane. And in the image directly to the right of that, we see the membrane removed and the bright white Syntec XP media inside, which shows no obvious exposure to dirt or dust, showing that the membrane effectively kept those contaminants out of the vent. The Syntec stack was then examined, and you can see that in the third image. The stack was removed, with the left part of the image being the top of the stack and the right part being the bottom of the stack. What you can see here is really just the bottom, the fourth of the stack, so maybe 10, 12 discs or so, shows evidence of liquid oil. And so this oil you can see in the far right image is mostly located on the bottom of the discs, which shows that this filtration efficiency throughout the stack is effective at capturing the contaminants before they reach the membrane. So in addition to just the physical examination, we also see that the airflow was minimally impacted and was far above the customer requirement in this application. So no water intrusion was observed. The membrane kept the vent assembly and the powertrain component free of water, and also the permeability of the vent was maintained even after high mileage of exposure. Here we have a screw fit example that we introduced earlier. This was removed from an ELSD component on a passenger SUV, and this had undergone on-vehicle testing in what our customer called a severe endurance test. So in the upper left image, we see the vent as it arrived and removed from component, free of damage. Second image shows the cap removed, and again, we see crisp and clear membrane on top with no damage visible. And then with the membrane layer removed, you can see that in the third image, we see the Syntec stack with no obvious contamination within. So the far right image shows the Syntec media removed, and the top of that stack in the image is the bottom of the stack in actuality, so it was inverted upon removal to show the area that would be most exposed to the oil aerosol. And here we see very little evidence of oil aerosol through observation, but in addition, we saw the high permeability maintained as well of the vent assembly. So no water intrusion was observed in this case as well, and the vent permeability was maintained throughout the test. Now, in addition to some of these other on-vehicle applications that are more passenger vehicle on-road applications, we also have worked with customers on testing in more rugged environments, such as the off-road UTV applications. So in this case, we do have a teardown from one of these off-road UTV vehicles, and this was done. This test was removed from a vehicle that was doing an off-road vehicle durability test. And so this is similar to the other durability tests, but much more rugged. There's mud riding, dirt riding, gravel road riding, water fording, basically the works of what a UTV would see in operation. And the product first arrived without any damage, but what you can see in that left image is definitely some exposure to dust and dirt and a little bit of mud cake there on the outside of the hose. However, once we go further in the inspection and open up the vent cap, we see just a little bit of dust and dirt deposited on the outside of the membrane. But again, in the third image, once the membrane is removed, we see no evidence of contamination of this dust or dirt crossing through the membrane barrier. The Syntex stack is seen in the image to the right, and the left part of that image is the bottom of the stack. You can see a little bit of evidence of oil staining, some level of exposure to oil. However, when we look at the airflow of the vent assembly, it is far above the customer requirement, and impact to airflow is minimal, despite the exposure to oil aerosol as well as the dust and dirt in the environment. So all in all, there was no water intrusion observed. It maintained a watertight seal, and despite its exposure to dust and dirt and other debris in the environment, it maintained high permeability. So in addition to application-specific on-vehicle testing, Donaldson also sought to test the vent according to more shared standardized tests, many of which were used in the design process of the drivetrain components themselves. I'm not going to walk through every component. This is just a sampling of some of the standardized tests that the vent was subjected to. Again, many of our customers have shown that their drivetrain and powertrain components are subjected to these tests and expected to pass. And so these requirements pass on to the vent as well as part of that system. So many of these standards are shared across regions as well as internationally. There are many ISO, DIN, IEC standards, and these cover things from thermal and environmental exposures through the operating temperature range, salt spray and salt fog, water ingression tests, spray tests like IP600K, as well as some structural tests for vibration resistance, mechanical shock resistance, those sorts of things. Again, this is not all-encompassing, but it does serve as a guide as to what validation has been conducted on the venting technology. And I think it stresses the importance of thorough validation on these venting components, especially given the unique scenarios of the powertrain venting world. So when you design and procure venting solutions, it's critical to understand the importance of venting powertrain components, and as Stan said earlier, to maintain your seal integrity and keep contaminants out while also keeping the oil within the system. Care must be taken to leverage the improved membrane technologies that provide protection for the water tightness and dust tightness of the membrane, but also allowing it to have long life in the applications powertrain venting with that oil aerosol contaminant. And thorough validation is also essential for establishing a benchmark to understand a long life of the venting component, as well as sufficient ingress protection on each unique venting application dependent on the drivetrain component. Just a little bit more about the venting group here at Donaldson. Venting group has supplied over 1 billion vents, protect various devices and enclosures from pressure change, liquids, and other harmful contaminants from their environments. These venting solutions are designed to enhance the product quality for our customers and their performance, and also increase our customers' productivity. And this is all done through a global support network. Here, I just want to show that we have some contact information if anyone wants to reach out to myself or to Stan directly. Our contact information is there. We also have our mailbox for general inquiries, as well as our venting website that you can visit if you wish to learn more. So right now, I'd like to say thank you to all of our attendees for your attention and for attending. And right now, we'd be happy to take some questions from the audience. I will hand it back to our host.
Thank you very much for that. So just a reminder for the audience, in order to ask questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click submit. So we already have some questions here, the first of which being, what is the best mounting location for the powertrain vent? How does the vent handle oil splash sling? Can it withstand oil purge?
Yeah, thanks for the question. So the powertrain vent is designed to be resistant to oil aerosol exposure, but it's important to understand it's not designed for resistance to liquid oil, say in an oil purge scenario, or if there's significant oil splash. So these are things to consider. While the vent does possess some liquid oil resistance, any pressure behind can force it through the pores of the Syntec media, which is designed for adequate filtration of the oil aerosol, but also drainage as well. So care must be taken to mount it in the correct location. Some of those things include mounting it outside of a dead zone or within a dead zone or outside of the liquid oil sling zone of the component. And also care must be taken in most situations where purge can be a concern that the vent have adequate baffling, protecting the vent port from this purge scenario.
Thank you very much for that. We have another question here. Can the vent be inverted during assembly and exposed to liquid oil?
Excellent question. Thank you for asking that. So, although some applications have shown that there is some level of oil resistance due to inversion, say during assembly or something, this is entirely application dependent, and in general, the vent is not designed for this type of resistance.
Perfect. Thank you very much. So we also have another question here. Do the vents become clogged after long-term exposure to dust and or dirt?
Thanks for bringing that up. So actually, I would refer back even to a couple of our teardown slides. So I think these help to illustrate the level of dust and dirt and even mud resistance. So the top of our vent is designed with small venting windows, and these provide water spray protection, as well as protection from mudsling and large chunks of dirt and debris that could get inside the vent. So even in the harsh UTV applications where they're exposed to mud and dirt and water fording, these vents maintain high permeability throughout all these contaminants.
Thank you very much for that. So don't forget, you can still ask questions via the Q&A widget in the top left-hand corner of your screen. We have another question here. Do these vents work on EV, HEV vehicles?
That's an excellent question. So our powertrain venting solutions, as well as the screw fit connection or the hose fit connection, are both designed to vent the air in a bidirectional way and also capture the oil aerosol particles in the air in both conventional and emerging AV and HEV powertrain components. If they have the similar specifications like operating temperatures, free air volumes, lubricants used, similar to the conventional type, then there are no changes required in the core design.
Perfect. Thank you very much for that. We also have another question here. Does the pre-filter material clog with oil over time?
Thank you. Good question. So this particular grade of Syntec XP, and this was chosen due to its ability to coalesce the oil aerosols in the airstream. We saw this in the crankcase ventilation applications it was designed for. So once adapted and once the theoretical filtration calculation was made, we found this suitable grade to work against the particles we see in drivetrain component scenarios. So what we see is that since this is oleophobically treated and we have sufficient efficiency throughout the stack, what we find is that this venting material does prevent buildup of oil over time. It allows it to coalesce on the fibers and resists any exposure to significant amounts of liquid oil as well due to its oleophobic nature. So in addition to the theoretical aspects of using this media, we also see in many different customer applications on various different drivetrain components that even after high mileage exposure, these vents remain open and permeable.
Perfect. Thank you very much. So don't forget, you can still ask questions via the Q&A widget in the top left-hand corner of your screen. We have another question here. Is the powertrain vent on road or in production?
Excellent question. So yes, this vent is currently in production and is deployed in multiple different applications, ranging from on-road passenger vehicles to the more rugged off-road UTVs.
Perfect. Thank you very much. We have another question here. How does one determine the amount of airflow required for a particular powertrain component?
That is a good question and a question that we commonly get. So to determine the level of airflow required for your specific venting, a good starting point is using a simple ideal gas law calculation. This can be done by using the free air volume that is present inside of the enclosure and calculating that together with the maximum differential pressure that could be experienced by both operating temperature range, but as well also by the maximum change in elevation. This is also called the Pikes Peak Challenge in the US. If you combine those two specifications together, it provides us with a worst case scenario and that we can look at the maximum differential pressure that will be present between the enclosure and the environment. And this can be a good starting point and help us further on in calculating the appropriate airflow required for this specific powertrain application.
Perfect. Thank you very much. We have another question here. What is the material of the vent body?
Good question. The vent body is made of 33% glass-filled nylon, also called PA66. This material was chosen for the balance of strength, temperature resistance, and resistance to common chemicals found under the hood, and so on.
Perfect. Thank you very much. So we have another question here. Were the UTV vents tested of the threaded type or at the end of a vent tube?
Yeah, great question. So this was also shown in the presentation in a particular example that we shared. These were the hose fit powertrain. So this particular customer had a hose, kind of a jiggle cap configuration and replaced it with the hose fit for ease of integration.
Perfect. Thank you very much. So we have another question here. How do you achieve such a high airflow rate but also keep out contaminants?
Yes, great question. Thank you. So these materials were chosen in such a way that we maintain a high level of permeability. However, the other component that we really considered as the other driver in terms of performance parameters is the water tightness. In addition to the natural dust tightness of PTFE membrane, which is shown in IP6X dust tests, there's also the water tightness we had to consider, and that tends to be the other more challenging contaminant to keep out. So while we choose a component with high breathability that allows for quick relief of pressure, either inwards or outwards, we also have a performance parameter of water entry pressure that we maintain a high level of. Now we chose this water entry pressure based on various different customer components and customer tests involving water fording to provide adequate water protection in addition to the permeability.
Perfect. Thank you very much for that answer. We have another question here. Can you use this tool in farm equipment?
Good question. I'll answer this kind of going back to what Stan said about the EV and HEV applications. If it's an application where there's a drivetrain component and there's a lubricant deployed within the component, and this requires venting, then the same core technology is going to be at work to protect those applications. So obviously every application is a little bit unique and specific considerations need to be understood. However, if the same core operation parameters are in play, then the same core technologies work well in those situations.
Thank you very much. So don't forget, you can still ask questions via the Q&A widget in the top left-hand corner of your screen. So we have another question here. Any development work done on OHW construction machinery?
So thanks for your question. At the moment, the powertrain venting line has been deployed on customer applications ranging mainly from on-road passenger vehicles of various applications, as well as down to kind of the UTV off-road applications. So at this time, no research has been done in that area.
Perfect. Thank you very much. We have another question here. Can I use these products in off-highway fleet?
Yeah, thanks for the question. I think I might need a little bit of clarification just on the application, but in lieu of having that clarification, I'll mention again, if it's similar drivetrain components with lubricants that are similar to those in axles, differentials, PTUs, then it's probably an application that this technology could work for, but that would require a specific study of that application. Please feel free to reach out as a follow-up outside of this presentation.
Perfect. Thank you very much. So we have another question here. Does this vent care about orientation, i.e., does it need to be vertical to function?
Excellent question. Thanks for bringing this up. So these vents are designed essentially to coalesce the oil aerosol. In terms of filtration mechanics, this can be done at any angle. However, what we want to do is to keep that coalescing stack free of oil buildup. And in order to get that to drain out effectively, this does need to be in a somewhat vertical orientation to allow for that drainage.
Perfect. Thank you very much. So thank you very much. If you didn't get your question answered today, they will be available to be answered in the coming days. So feel free to keep sending. So that just leaves me to thank Dustin and Stan for what was a great presentation, and to Donaldson for sponsoring this session. To the attendees, you will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group, Business Review Webinars. Thank you all once again, and I hope you all have a very pleasant day.